Question 4. The braking distance of a vehicle is defined as the distance traveled from where the brakes are applied to the point where the vehicle comes to a complete stop. The speed s and a braking distance d of a truck were recorded. This information is summarized in the following table. This information was used to create Model A, where d is a function of s greater than or equal to 0. Model A, d of s equals ps squared plus qs, where pq are integers, at a speed of 6 meters per second. Model A can be represented by the equation 6p plus q equals 2. A second equation to represent Model A when the speed is 10 meters per second. Check this table. When speed is 10 meters per second, the braking distance is 60 meters, which means this is speed, this is distance. We do have a function d of s equals ps squared plus qs. So we need to plug in d of s, that distance is 60, equals p times s is 10 squared plus q times 10. Simplify. 60 equals 100p plus 10q. Common factor is 10. Both sides divided by 10. We got 6 equals 10p plus q. This is the solution to question A. B. Find the value of p and q. Since we already given two equations about p and q, what we need to do is set up a system of equation. 6p plus q equals 2. 6 equals 10p plus q by GDC. Let's go to Scratchpad. Menu. Algebra. Solve system of equations. Enter. We have two equations. Variable is PQ. P, comma, Q. Enter. Put in these two equations. Enter. P equals 1, Q equals -4. P equals 1, Q equals -4. C. Find the coordinates of the vertex of the graph y equals d of s. We substitute the value for p and q. 1s squared minus 4s. Simplify. S squared minus 4s. But when we put this into calculator, make sure variable we need to change into x. Go to graph. X squared minus 4x. Enter. we need a vertex. Menu, analyze graph. This is a minimum, so go to 2. Vertex is a 2, -4.
By graphing vertex
2, -4. E. Using the values in the table and your answer to part B, sketch the graph of y equals d of s. For s greater than or equal to 0, less than or equal to 10, d is greater than or equal to -10, less than or equal to 60, clearly showing the vertex. For AISL level, make sure when you sketch the graph, you have to set up a complete coordinate plane. Second, make sure when you sketch the graph, it is a smooth, correct curve. The third step, make sure you show the key features asked in this question. In this question, we need to show vertex. Also, we need to use the value in the table. So we have to use these 3 points. First of all, let's set up a coordinate plane. Origin. In this question, speed is x, distance is y. Don't forget the unit. Speed is from 0 to 10. It didn't tell us what the scale, so we create the scale as we like. Let's do 2, 4, 6, 8, 10. For D, let's use -10, 10, 20, 30, 40, 50, 60. Then explore the points. Vertex 2, -4. It's here. 0, 0, 6, 12. 10, 60. Then smoothly connect these 4 points. Let's go to E. Hence, identify why model A may not be appropriate at lower speeds. From the graph, we could say the distance is -1. The speed is low. It's a negative braking distance at a lower speed. Additional data was used to create Model B, a revised model for the braking distance of a truck. Model B, d of s equals 0.95 s squared minus 3.92 s. Use Model B to calculate an estimate for the braking distance at a speed of 20 meters per second. So we got distance of 20 equals 0.95 times 20 squared minus 3.92 times 20. 301.6 meters. G. The actual braking distance at 20 meters per second is 320 meters. Calculate the percentage error in the estimate in part F. VE is the exact value. VA is the approximate value. So we plug in to this formula. This math book, enter, we got this absolute value. Control divide, get this division line. 301.6 minus 320 over 320. Then times 100. Enter. 5.75%. So percentage error equals 5.75%. Let's go to H. It's found that once a driver realizes the need to stop their vehicle, 1.6 seconds will elapse before the brakes are engaged. During this reaction time, the vehicle will continue to travel at its original speed. A truck approaches an intersection with a speed s. The driver notices the intersection's traffic lights are red and they must stop the vehicle within a distance of 330 meters. Using Model B and taking reaction time into account, calculate the maximum possible speed of the truck if it is stopped before the intersection. 330 meters equals 1.6 times s. This is the reaction
Distance that truck traveled.
0.95 s squared minus 3.92 s. Since this is a quadratic equation, we can solve it by polyroots. Move 330 to the left side. 0 equals 1.6 s plus 0.95 s squared minus 3.92 s minus 330. Go to polyroots. So we put this function into calculator, control menu, math action, find roots of polynomials, enter. We are given two solutions. The positive one is the correct answer. Polyroots s equals 19.9 meters per second